combinatorics and probability. Let's understand what is combinatorics. Combinatorics is, so let's understand why we need combinatorics for probability. So what is probability? So if you go to the history of probability, you will see that probability was built in the, in the gambling sector, where people were asked to, so they were asking like this, like, what is the chance of winning?
Sure.
For example, I will tell you this game. In this game, a person has to, in a round of 10, die throw, 1, 2, 3, 4, 5, 7, 8, 9, 10. In a round of 10 die throw, if one gets more than 24, that person wins. This was the game. All loses. So the person who made this game lost once. His intuition was this, okay, his intuition. He didn't do it mathematically. So then sort of this motivated to ask that what is the number, like whether it's 24 or 25. And it turned out that 24 ke liye, the number that you personally get 24 sum, sum of 10 die throw is really not like, what should I say? So one has to count all the die throws that will give rise to 24, okay? So that turned out to be really less than 50% or around 50%. So maybe you can count that when you learn. So this was the idea. This was a starting point of mathematical formulation of, because there was the aspect about losing millions, not millions, but yeah, lots of money. So they wanted to really be very clear about the mathematics, the measurement wanted to be very clear. So they wanted to make it very mathematical. So suppose we wanted to try to understand that what is the person, like, what is the chance of winning? If the person goes towards that, we get that we need to understand the 4 basic aspects. The sample space. So what is the sample space? The sample space is all set of all possible outcomes. It's an experiment. So it's an experiment. First of all, we start with an experiment. The mathematical formulation starts like this. Experiment. So here the experiment is what? Let's say sum of 10 die throws, or maybe 10 die throws. Okay. 10 die throws exactly. The experiment is 10 die throws. Understand this, we will understand it very carefully. So for this experiment, there are certain possibilities of, like, one possibility is that 1, 2, 3, 4, 6, 5, 1, 2, 3, 6, 3. This is a set of all 10 die throws. What is one possibility? So what are the total possibilities? That's the first question. So it is a set of all possibilities. This is a starting point of combinatorics, okay? In the historically, set of all possibilities. So what is this called of the experiment? This is called the sample space. This is called the sample space. So it's showing 10 dice, and this set of all possibilities is called a sample space. So understand that here we're interested in a special subset. We are interested in all those elements X inside this sample space such that sum of those elements in X, or maybe this, let's call it X1, let's call it X2, let's call it X3, let's call it X4, let's call it X5, the through values, okay, understanding?
Yes.
Such that, let's call it X vectors there. This is the X vector in some sense. So that summation of xi, I from 1 to 10, you 10 throws are there, na, is more than, is at least greater than equal to 24. That is the event. That is right. That is the whole thing we are looking for. Understanding, Pranjal?
Yes, sir.
So we are looking for all those cases where the sum is greater than equal to 24. Okay. This set is called an event. It's a subset of the entire sample space. Okay. Okay.
Yes.
Now try to understand the following. So what we have got over here now, we have got experiment idea. Okay, we have got sample space. We have got a specific event. It's a subset of the sample space. It's like this. Sample space is like a set of all outcomes over here. I'm just giving an example. An event is a specific element. This one, this one, this one, this one, this one. Okay. Can you see, Pranjal, this I marked?
Yes, sir. Yes, sir. Yes, sir.
Good. So that's an event. Now my question is that so therefore, if I ask you this for this basic idea, this was how a probability is developed. For this basic idea that what is the chance of the event E? What will you tell me?
What is the chance of event E?
Yeah. This is a set of all possible outcomes. An event is actually preferred set of outcomes, a required set of outcomes.
So it's E over sample space.
What E is a set, okay? E is a set. This is also a set. You're right, you're almost correct. So what we should tell exactly?
Set of E divided by set of sample size.
You're right. You're telling E by summation, E by this, right?
Yeah.
But E is a set. You cannot divide two sets. What exactly you are meaning?
all the number of values in
Yeah, the
both the
number of
sets.
elements. This is called cardinality. Note, this means number of elements in A, right? This is a real number, so you can divide by real number. This is a very good example of probability. This is actually the basic definition of classical probability. So understand that why does this stem the requirement of combinatorics? So this idea, how to count, this naturally questions are asked that how to count this number of elements of this. This is what is called combinatorics. Combinatorics is the math behind counting
It's
number of elements of a set. So this makes sense. So this makes also an assumption. Can you tell me what is an assumption that it's made here?
assumption made here.
Pretty big assumption is made here. You tell this event, this can only happen if all the values of a die are equally likely. It can only happen in this. Suppose a die has more probability, more chance of getting 6 and 5 than 1, 2, or 3 or 4. Then what will you get? You will get more 6 and 5, right?
Yeah.
So over a step of 10 draws, it will be tending to more than 24, right?
Yes.
So the chance of getting more 20 more or more will be getting higher, right?
Yes, sir.
That is not explained in this model. This is a shortcoming of this model of probability. So people couldn't do this for like decades, couldn't solve this idea for decades. Even these people who solved the previous problem couldn't assume the previous one because they were missing something. I will tell you what they were missing. They were missing this basic description. So we need what? We need a probability now to give to this outcomes, to this event, right?
Yes.
Yeah, tell me your doubt.
Yes. So, what was the name of this probability, which is set of the number of elements in set E divided by number of elements in set, number of elements in sample size.
The number of elements. No, I
Yeah.
told that what you told a very good idea is that we need to tell that number of elements in this event by number of elements in sample space. That is a basic definition. Like you can tell that, okay, this is a basic intuitive definition. But here we made an assumption that it's a equally likely. So I told that to understand this, to calculate this, we need to learn how to count the number of elements of a set. The math behind the number of elements of a set. Count. That is called combinatorics.
कॉम्बिनेटोरियल सर
Or
नहीं मेरा क्वेश्चन ये था ये क्या लिखा है
दिए,
ये
can you mark?
यस
ये
सर
classical probability, classical probability.
अच्छा
Okay, so we need a different idea of probability. Okay. So therefore, what we need, we will move here to two directions. So we have got sample space. So we have got experiment first. To understand an experiment, we need sample space. And then we want to find the chance of some event. The event is usually a subspace of the sample space. So from a sample space, we can have multiple events. The collection
yes
of
sir.
events, all such events. So events are on which, so just a note definition, note, here also a note, the set of all outcomes. Note, number of, okay, it's a collection, okay. Event is something to which you want to assign probability. Want to assign probability. The sample space is also an event. It's a set of all events, a set of all like outcomes. So उसका probability क्या है? Naturally बोलो. Always.
सर वापस एक
The sample space is also an event. It's a subset of the sample space, right?
yes sir
Its exercise is that sample space is also a subset of sample space. So tell me what is the probability of sample space, therefore?
1
Right, 1.
100%
Right, 100%. Set of all outcomes, uska probability always 1. Perfect. So now the collection of all this, we need a collection of all events. Like collection of all those events on which we can assign probability. It is called this. It is denoted by this. Okay.
okay
It's like collection of all books, collection of all events on which, because we want to assign probability to something. This is a collection of all events I want to assign probability. And then uske baad aa raha hai, we need something like, we need to find a probability function. This is what you are yet to learn. Probability function kya kar raha hai? It will take one element, take each event and assign probability. Take each event and assign probability. Okay, this is a probability function you are yet to learn from me. Any doubts till this point, Pranjal?
yes sir yes
Yes.
sir so my doubt is what is the difference between event and collection of event
Oh, it's the event is like, what is the difference between a book and collection of books? I will tell you,
okay
ये मिला के बोलता है probability space.
मतलब ये ऐसा हो जाएगा कि मतलब गेटिंग वन फ्रॉम अ डाइस और मतलब वो 1/6 हो जाएगा लेकिन कलेक्शन ऑफ इवेंट्स वुड बी गेटिंग 1 2 और 3 फ्रॉम लाइक
No.
डाइस
Collection of events is like, it's like instead of mentioning each of the possible, so probability space का मतलब ये है कि we need a total set of outcomes. Okay. Some set of why we need a collection of events, because as you will understand that all subset of a sample space is like, I will write it as a very big thing for note. in advanced probability, we will find out, like maybe you will find out someday, that all subsets of sample space can not be assigned probability.
Sample space.
So what is an event? Event are defined as a subset of this, right?
Yes, sir.
So collection of events are those. So you can tell, like, then we can take set of all subsets of sample space, which is called the power set of this. We can take that, but the idea is that all events, all subsets of the sample space cannot be on like cannot be assigned a probability. I mean, there are examples like that. So that's why what we need, so this we need this. We need the set of all outcomes. We need the set of all events on which we can assign probability. And we need what? And we need a probability function, the probability assignment. That is the idea of why we need to define this set of all events, collection of events. So those are all possible sets on which we can assign a probability. Okay, that's you understood now. Hello.
हाँ, I understood. मतलब समझा तो I understood more, but I पूरा नहीं समझा. मतलब थोड़ा सा still like मतलब what does this mean? मतलब कि मतलब how can some subsets not be assigned a probability?
Okay. You want to know those type of, because those type of sets are some, like, it's a very different sets, you know. Those are very intricate sets. Like, I cannot make you understand because you don't have the mathematical knowledge. So that's the
Okay.
thing. I mean, for any discrete, any count, like any discrete finite space, all set of events can be assigned a probability. But for infinite sets, all set of events cannot be assigned probability. Okay.
But why?
Yeah, but why means you have to understand there is a concept of infinity. So you have to understand that why all sets cannot be assigned probability. If I give you the picture that all sets cannot be assigned probability, you will get confused. Like you will not understand. So I'm not trying to confuse you more, but you can understand. It is a fact that all sets cannot be about. Maybe you can read about it more. It's like exercise for you. But I cannot explain you as a teacher now, given the knowledge you have. That's the idea.
Okay.
Because I learned it when I am in master's first year.
Achha.
So you will learn it maybe after like around that time, second, third year or first year master's, bachelor's, third year, master's, first year. So you need to wait for it. Sometimes you have to wait for good things, or you maybe like learn yourself a lot to understand that in your 12th. But there are certain elements on which we cannot assign probability. So let me search if I can show it to you. Just give me a moment. Events on which we cannot assign probability. Vitali set are some sets. Okay, what is a Vitali set? I will tell you. Oh, this is a set. I've got it. Can we paste on Zoom? This is a very bad thing. We should able to paste things on Zoom. Huh?
I don't think so. We can.
Okay, Vitali said is a subset. Can we type text on Zoom?
Yes, yes. हाँ,
ये क्या हो गया?
it is a subset that displays is a subset V or the interval 0, 1 of real numbers such that for each real number there is exactly one number V in V such that V minus R is a
A
rational.
very complex set you can understand now. Maybe you will not be able to visualize it. It's a very complex set. We cannot assign probability to this. It's a subset of real numbers, right? Subset of this, right? So this is a, if this is a sample space, we cannot assign probability to this. Why? That's a very big thing, but we cannot assign probability.
Okay.
Therefore, we cannot take set of all subsets. We have to select all those elements. How to do that? That is a part which is called measure theory. But we are not going to do that. Okay, we are going to understand probability in a very easy fashion. Okay, let's not dwell into this.
Okay.
Otherwise, our focus will be detour. Like, you understand. I gave an example, asked for it,
Yeah.
but yeah, I hope you understood now. It's better.
Yes, sir.
Yeah. Maybe you can do it like understand how we can. So this is the basic idea of probability. Okay. So now this probability function. So what we have, what we need this sigma. We need this set of all events, and we need this probability. Function. Set of all events and probability function. This together is called probability space. This is a basic understanding of probability space. ठीक है?
Yes.
So for that, let's count. Let's do a problem. Concept question. Let's say the sample space is 1, 2, 3, 4, 5, 6, 7. 7 facet die. And this is the state, all subsets of sigma. Find this number of elements of this. So इसमें क्या है? इसमें ये है 1, 1, 2 है, 1, 2, 3 है, 4 है. You understood?
Yeah.
Set of all subsets. Find the number of elements is this. So that is equivalent to find number of
subsets. Yeah.
Okay.
Possible.
So think about this.
null set comment होगा null set होगा count so one null set one null set 7 scale those scale में there would be so this is 42 yeah 42 होंगे 42 होंगे
Okay, you think about this question and tell me after the class, okay? You try out this question. I will not tell you in this class. Okay, so there are two things left. We need to really understand probability, the function probability, and the understanding how to count the number of elements of a subset. We need to understand that. And if we need to understand that, we need to learn combinatorics.
Yes, sir.
I will tell you today, my plan is I will tell you basic things about combinatorics. So tell me what you know in combinatorics. Do you know anything in combinatorics?
So what all comes in
Permutation combination mainly.
Yeah, I know permutation combination.
In its entirety.
Huh?
You're good at it? You're good at it?
Kind of.
Good. Best. Then I will not do this stuff.
Right now I was just using permutation. Well, right now I was using combination to find the number.
Okay, tell me the solution then.
So just a second. So 35 is not 4. 70 plus 42, 112, 119, 128.
How did you find that?
I found the like the report. So basically, first of all, number of nulls, possible null sets that will be 1. Then the number of possible subsets with 1 element, that is 7. Matlab, total number of sets would be 7. Subsets would be 7, and then for 2 it would be combination. It would be 7 choose 2 combination. So that is 21. Then 7 choose 3.
Okay, fine,
25.
good. So there is a
35,
result I will tell you. So you know about permutation combination. So you know about addition principle and multiplication principle, right?
Mm, what does that mean? I don't know.
Okay, I will teach you this and I will show you the solution. Like the basic of counting is addition principle and multiplication principle. So what is that? Addition principle is like you have to go from here to here, or you must do something here to here, and you have m task and n tasks left. You have two ways of doing it. One is by m task and one is by n task. How many ways you can do it? M plus n ways. Okay. How many ways you can do it? M plus n ways. Right? Suppose
Sir,
you have.
can you repeat the question?
Sure. Let's say you can.
Yeah, acha. Okay, by one way you can do it m by one thing you can do it by m ways, and by the other thing you can do it by n ways. So the total number of ways in which you can reach the final outcome, right?
Yeah, is m plus n.
Yeah. Okay.
Now, if you understand, this is almost like series connection in electrical engineering. Okay, because series connection. You're doing it m ways, so the number of ways to do it is because it's like also addition principle is known as or. It's like we can do this way or this way.
Yeah.
Okay, 1 second. Okay, so this is the or principle. This is like this way or that way.
Yeah.
Now multiplication principle. For multiplication principle, it's like this. You have to go from here. It's like a parallel connection. It's like a parallel connection. Sorry, it's series, not series, parallel. For multiplication principle, you have to go from here to here via another path actually. Same thing. It's like you have to go first through here. It's like and. This is called and. Like this and this. So it's like A to B and B to C.
Yeah. And then it will be AB times BC because
Right. That's
it can
M
be
and N.
considered as a permutation.
Yes, like M times N. Not permutation in that sense, but this is like M times N, okay?
Yeah.
Number of ways to
Yeah,
go
yeah.
from here to here. So that is the AND principle, and that is the OR principle. Like M times N. So if you have, so this is, you will understand something when I will teach you. It's like related to conditional probability. Okay, this is like, I will see it's the multiplicative theorem of conditional probability. and there is additive theorem of multiplication. That is like law of probability. Good. Fine. So this is the basic of addition principle and multiplication principle, and
Yes.
then there is permutation. Permutation is this, that it tells you if the number of ways of permuting or arranging n elements distinct, okay,
Hmm.
in R places. How to do this? It's simple.
In factorial divided by n minus r.
Yeah, that is R. That is if it's n places, that is true, but here it's this. So let's try to understand NPR. So how we can solve this using multiplication principle to understand this? Like first place has how many options? N options.
Yes.
The second place has n minus 1 options. The and.
Hmm.
Okay.
Yes, sir.
This and this. And
हाँ.
this.
Yes, sir.
And this.
समझ गया.
Yeah. So this is coming out to be n times n minus 1 dot dot n minus r plus 1, which is NPR, which is this.
Yeah. And
now when there is no arranging but choosing, what happens is that, let's say this star,
the order doesn't matter.
Yeah, order doesn't matter. Perfect. So it turns out that we need to divide by r factorial. Because for every r elements, there is r factorial arrangements. Since the order doesn't matter, we need to divide by it. So this turns out to be n choose r.
Yeah.
Okay. This is the basic.
Yes.
So you are quite good at it.
Hmm.
Perfect. We don't need this discussion more. So just one thing I will end today's class by that problem. So I will tell you what's our next day's plan too. I will tell.
Yes,
Let's see. So understand this now, that what we have done till now. We have understood how to count the number of elements of a set. Now understand this very carefully, that you have told number of elements of a subset, number of subsets of a set. How to count this? We have told that n choose 0 plus n choose 1 plus n choose 2 plus n choose n. You told it's turning out to be 1, right? You'll see it will turn out to be 128 or 2 to the power n.
2 raised to the power 7.
Yeah. Now why 2 raised to the power 7? We have two proofs out here. The first we will need this is binomial theorem. We will do this while doing binomial distribution too. Another is bijection principle. Understand this, we will do this now. Let's do this. So we need to subset, right? Now we will codify the subset like, let's say 1, 2, 3, 7. So what we will do? We'll take this codifying idea. What we'll do over here? We will. Let's say if I write 0, 1, 1, 1, 0, 1, 0. What is this codified equivalent to? It's like in this is a set where we keep only the one, that is 2, 3, 4, and 6. You understood?
Yes.
Okay. So understand this basic idea that every subset can be written as a binary string of length 7. This is called a binary string, 0 and 1 ka.
Okay.
You to understand this idea.
Yes.
Tell me any subset of this 1, 2, 3, 4, 7. I will give you a binary string. Any subset bolo?
1, 3, 7. 1, 3, 7.
How will you write it? 1 के जगह 1, 2 नहीं है, so 0.
0, 1, 0, 0, 0, 1.
Perfect.
Yeah.
So therefore, every subset can be written as a binary string of length 7, right?
Yes, sir.
So therefore, the question rises that how many binary strings of length 7? Right? Did you understand?
By multiplication theorem.
Yes.
Every place has two possibilities, 0
So
and
2 into
1.
2 into,
So
right?
2 into 2 into 2 into 2.
Perfect.
2 to the power 7.
So there's a different way of proving it. Now, how to prove this that you told? Let's do binomial theorem. Let's take this one. X plus 1 times x plus 1 times x plus 1. If you do it, what will you get? You will get
X n.
Let's say first will you get x square plus 2x plus 1, then you will get x plus 1, so you get x cube plus 3x square plus 3x plus 1. Okay?
Yes.
Let's try to understand what will you get if you get this. X1, x2, and x3 I put it differently. Let's say what will you get? You'll get x1
x1 times x2 plus 1 plus x1 plus x2.
again you get here. So what do you get?
x3 plus x1.
X1, x3.
x1 x3 plus x2 x3 plus x3 plus x1 x2 x3 plus x1 plus x2 plus x1 x2 plus 1.
Right? Right?
Okay. Yes, sir.
You get this entire idea. Now try to understand this. What is this? So what we get over here? We get 1 x1 x2 x3.
Yes.
So x1 x2 x3 plus x1 x2 plus x2 x3 plus
Plus x3 x1
x1 plus
x1 plus x2 plus x2.
right?
Plus 1. Yes, sir.
Now what is exactly this? This is what?
This is
The sum
number of
x multi. So if you like, here what we want. Now if we put x1 x2 x3, what will happen? X1 equal to x2 equal to x3. What will happen? This will happen to be x cube. This will happen to be
Yes.
plus some coefficient into x square plus some coefficient into x plus 1, right? What is this
Yes.
coefficient? That is, understand how can x square be formed? By taking two elements at a time.
Yes, sir.
So taking two elements.
3 choose 2.
Exactly.
Yeah.
That's why turning out to be 3 choose 2. Here taking one element, that's turning out to be 3 choose 1. You understand?
And 3 choose
For
0. उसके बाद वहाँ पे 3
for
choose
1
2.
plus x plus 1 plus x whole to the power n, for x to the power k ka coefficient will what? It will turning out to be all possible k combinations of n, right?
Yeah.
So that will turn out to be n choose k.
And k choose k. हाँ.
So therefore we have got that this is summation from k to 0 to n. This is the binomial theorem. Now in this binomial theorem, we put x is equal to 1. We get this result. See, left hand 2 to the power n, and here we get, that's the idea. Okay, so we got two different proofs of this. You understood? Any doubts?
No doubts. उसके बाद फिर when we further simplify this, we finally get 2 to the n.
Perfect.
मिलनी चाहिए.
Yes. So that's the idea. So it is a basic of combinatorics and probability to you. So next day our plan is to start with the sample space, the probability space, and understanding the probability function. Okay. And then we will move ahead to do some probability problems, and then we understand conditional probability. It's the main aspect of this. Okay.
Okay. Yes, sir.
Okay. Every single day you will be one step ahead of all the people who are doing in bachelor's and learning mathematics and probability and statistics. I'll make sure that happens.